Good morning, everybody. My friends in Korea and Hong Kong and worldwide. As Dr. Seo introduced me, I have worked in Hong Kong for 4 years from 2013 to 17, and then I'm working now at Incheon National University in Korea. I'm going to talk about how we move precast concrete components to site every day, and then how we can actually make it or move them in an efficient and effective way. And actually in Korea, similar to other parts in the world, Korean government try to facilitate the use of offsite construction theories and management to improve their productivity and solve some sustainability issues and safety issues of labors. And then we have studied as a consortium of researchers. We have studied the research on offsite construction management from 2020. Actually, we have gone through 1 year of a sort process to find out what topics are very useful and then doable in Korea. So we find some topics, and then according to those research, we initiated the 4-year projects from last year, and this is the 2nd year of our 4-year journey. And we are expecting more of a research outcomes and techniques and tools in the coming years. And the research includes different topics because we are a consortium of many researchers and industry people. So it ranges from the design and engineering issues to production and transport and installation, and also we cover some education and policy development. So this is a very big projects we're doing. And then I have done some research on transport issues, which is related to supply chain management and project simulations. And moving materials, the PC components, we are doing so, but actually it brings new source of risk to our project, because all of those components are critical. When one PC component is delayed or damaged, that it provides significant impacts on our cost and schedule performance. And we need to know that all of these components are very heavy. We cannot actually handle manually. So we need the capacity of lifts or cranes. So it actually gives more of a complexity in our project. But what we found is that there is a lot of rooms to research in transportation. So some research topics about manufacturing and then assembly that has been studied in earlier years before, and followed by the planning and design researches here. Sorry. And can you see the mouse pointer of me? Okay, good. But we see that the research about transportation solely is very few. Also, when we look at the market, there are several tools in the market that help us to do logistics better. But most of the tools in the market are for general use, right? So it cannot actually be directly used for moving precast concrete in construction industry, because we have different considerations and rules. For example, we have tonnages, that's between the slabs or components to prevent the damages of a PC components. And in construction, we have we found one software that is called WMF Stacker, but this is for lightweight panelized walls. So it has different considerations than moving the precast concrete, and then it has its own limitations, but that's actually beyond of our discussion today because we have very short time. So we have limited knowledge and actually tools for moving precast concrete components to site. And when you look at the steps or simplified steps for moving those components to a site, you see that there are different steps here, and then they have different perspective. Different people have different perspective and the idea about what's good transportation. Okay, and then they are doing these steps manually because we don't have knowledge and tools. So that's a problem I see. So first of all, we have site managers on site, right? Site managers, and then these guys, check the installation sequence, and then decide on the materials that needs to be delivered on the next day, and then they order for delivery to the factory, right? And then the document includes the pairs of components and vehicles, meaning that we have these components to be delivered, and then these components are mapped onto different trucks or vehicles. And then, those trucks needs to be, come to site on which time, right? We have that information. And production managers on factory, right? These guys actually coordinate on the order for delivery because they have different information. And then when they settle the order or the pairs of components and vehicle, they order trucks, right? And then load the components onto trucks, right? And then in that steps, we need to make a stacks, because we want to put more of the materials, more of the components onto one truck to save the transportation cost. And then transporter move the materials onto site, right? And in Korea, we are doing this, we are moving or transport the components of 2.5 million tons per year. And then which is equivalent to, according to our study, 25,000 hours for planning transportation. And all of these steps are being done manually. So, they have different perspective, firstly, right? So site managers try to ensure the JIT delivery. They want those materials when they need to build, when they need to install. And they want to minimize the reshuffling on site. So, materials are delivered on stacks, right? So when you have different wrong installation sequence on stacks, you need to put some of the materials on yard first, and then you need to install the second one first, right? So this is called reshuffling. So they want to minimize reshuffling on site because it requires the use of people and the cranes. And the production managers in the factory, they want to maximize the stability of stacks. They don't want the materials are damaged during the transportation. Right, so they want to maximize stability of those stacks on trucks. And transporter, of course, they want to satisfy the regulations. And you need to know that typically site managers and production managers from one entity or company, meaning that one PC factory or company, they produce the material and they install on site those materials. And those people, these guys want to minimize the number of trucks, right? Number of vehicles, because normally this is under contract, unit cost base. So they want to reduce the number of trucks, right? So all of this needs to be satisfied, right? And then or optimized somehow, but we don't have a tool or knowledge. So we are still under research, and then we are under but we are doing several researches on solving this problem. So one thing is, we try to automate the generation of PC component and vehicle pairs by integrating the information of components and yard on site and trailers, right? So we have done some experiment, like a sort of simple experiment, and then we asked eight experts to do the pairing work, by giving them some example like scenario, and they spent like 15 minutes and and generate like 0.9 errors per experiment, and then they on average use a vehicle of 6.5, right? 6.5 vehicles they ordered to deliver all of the materials we give to the participants. And but using our tools, we can reduce the time and we can reduce the errors, and then we can actually use reduce the number of vehicles used to 5.5 by utilizing more of yards, because yards, we already have those yards on site. So we utilize more of yards to reduce the number of vehicles. So, our method can, ensure JIT delivery with this number of vehicles legitimately. And second research we have done is about, loading on vehicles a component by developing a method for automated generation of PC slab stacks. So how to make stacks, right? So, we integrated information of components and then trailers and then tonnages. And then we heavily consider the rules about tonnages, how to locate the tonnages, right? So we have done similar, experiment, and we also find that we can actually reduce the time for generating stacks. And then we can actually generate stacks with no errors. And then our stack, the stacks generated by our method, have a better stabilities and also the reshuffling numbers. So we can reduce the reshuffling, but at the same time, we can increase the stability than the experts. That's our findings. So we can deliver the materials in stable and easy way for better use of installers. So this is what we have done the research. We are still in the finalizing the work, but simply speaking, this is what I try to do with the transporting materials. If the time allows, can I show this? It is like 1 minute videos. So this is like our lab results. So for example, you initiate the projects, and then sorry for the Koreans here, but we generate the list of components, PC components with the width and other like installation sequences, etc. And then it automatically generates the stacks like this. So actually, you can see for each stack, in what way the individual component has been stacked here. And then if you're satisfied this, you can just see the 3D visualization. And then you check here also, and then you can modify a little bit here also, right? And once you are satisfied with this plan, you actually generate the report. So when you move the material to site, you can actually send the report to the site guys, so they actually can see how, in what way all of these materials are transported to site. They can prepare, right? So this software we have developed now, based on this, we are developing the web-based software as a SaaS, software as a service. So we try to improve the applicability of this software for the use of practitioners in the industry. And what we can do with moving construction materials. So some of my idea here for further study is, I try to link the beam with the transportation support system with the API. So, to increase the applicability, so people can, don't need to input all of the information about the materials onto the software. So, it can improve. And also, when you look at this figure, this is for Samsung factory, and then they have a screen here, and then they don't think about how to stack all of these goods on pallets, because how to put those goods are shown here on the screen. They just follow, right? So similarly, when we facilitate offsite construction, we see a lot of materials, transported to site in the future. Then, we will see some of the guys who are putting all of these stacks, right? All of these components on the trucks. So we can use a HoloLens or some AR technologies to give them instruction how to put those things stably, right? And then in a way that the installers on site can easily install the materials. And another thing I want to tell you is that now we have a stacking data, component stacking data. Before, because we do this stacking manually, we don't have those data accumulated or sent. But when we have some automated method or formalized method for stacking materials, then we have a new data of a stacks, right? So we can actually use those data to simulate and optimize process flow of offsite construction projects. And now our research group is moving forward to develop automated sequencing of a material installation, because that's better. So you can have a better installation sequence, then everything can be solved in a seamless way. So we are doing those researches these days. Okay, so this is all I have prepared for today. If you have some questions, we can talk actually in the later session. So thank you very much.